Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In the last video tutorial, we performed the supervised classification using the LandSat images, and specifically LandSat 5 image, and we also determined the level of overall accuracy of the classification based on our sample of ROIs, or our training sample. So we performed the classification, as I said, based on LandSat 5 images, and I made the important point is to make sure that when you place your ROIs or your training samples, that it corresponds with the feature of the LandSat 5 image and not the satellite image because of the time difference. So that's a very important point to emphasize, and also remember, the more ROIs or more training samples, the better, etc., etc. So in this video tutorial, I'm going to look at supervised classification, comparing LandSat and Sentinel, and also comparing the normal classification method with the random forest classification to determine which one is better, which one is worse, if there's any differences, etc., etc. Okay, so that's what this video is going to be all about. So I go to my Earth Engine, I go open my code editor, I go to the scripts, I found my project name, my script name, I've saved it as Daytime Tutorial 7. You can see there's the script name that I've saved it. Remember to always save and run, save and run, save and run. Always important. Okay, so let's start again from the beginning quickly. I have my regions of interest, and specifically I'm looking at this region of interest, which is a municipality within the district. Remember, I used to work with the district, but I made it now a smaller area, which is a municipal area, simply because of the loading time, etc., etc. So then we created our features, or our classes, or our categories of features, and we have 6 of them, which is water, vegetation, urban, soil, and soil, mountain, and urban. 1, 2, 3, 4, 5, 6. Yeah, 6 classes or 6 categories of features, and then we've created a collection of ROIs or training samples for each of these categories or classes. And you can see we've at least have a minimum of 50 for each of them, and that, as in the previous 2 videos, basically using this function here, geometry inputs, to create our ROIs or training samples. And there they are with the corresponding colors, and I have labeled them again class, and starting from a value of 1 to 6. So there's class 1 is water, and then class 6 is urban with the colors, etc., etc. Okay, so then in this case I'm only going to work with LandSat 8 and 9 for the specific reason, or for the sole reason, that Sentinel only, for my region of interest, is only available from 2019 and onwards. So there's no point comparing using LandSat 7 or LandSat 5. Okay, so I'm creating my median LandSat 8 image for 2019. I create my median LandSat 9 image for 2013. So they are unique for that specific periods. So they will have features, display features for that specific period. There's no overlaps, and it's a median, which we suggested is the better option. Now you can play around with the mean to see whether that gives you a better classification. That's up to you. And then the Sentinel, we've got our cloud masking code there, and then we create a median 2019 Sentinel image. I call that Sentinel 1 or Sentinel image, again a median. And then we create a Sentinel image for 2023, which is also mean, and I call that Sentinel 2 image. Okay, clip, pixel, cloud masking, etc., etc. Then displaying for this particular exercise, I'm only going to look at the 2023 period, but obviously you can include both periods, but that's up to you. I'm only going to look at the 2023 period, and I'm going to compare the LandSat 9 image classification with the Sentinel image for the same periods. Remember, Sentinel-2 only refers to the second image. It doesn't have a specific purpose except for it's a second period. Okay, well, the 9 in LandSat 9 has a specific period because it refers to that satellite or that data set. Okay, so I'm going to compare the LandSat 2023 image with the Sentinel 2023 image. I've got my class. Okay, remember that's your classes that you've named your categories or your features, and I'm going to give it another name, which is label. And then we know that the LandSat 8 bands that we're going to use is band 1 to band 7, and the Sentinel bands we're going to use, we're not going to include band 1 because that's coastal aerosols. We're just going to use from the true color, and we're going to go straight through to BandSat 12. Okay, so there's our bands for LandSat. Sorry, there's LandSat 1 of LandSat 9, which includes the aerosols, and it goes up to the second shortwave infrared. And then from Sentinel, we don't include band 1 of the aerosols. In fact, we actually should. But yeah, we only started from the blue band going straight to the shortwave. Remember, then you've got these extra bands, which is near red, and I can't remember all the names. You can obviously go to the landing page. But we actually should include, if we include the aerosol band in LandSat, we should include the aerosol band in Sentinel. But anyway, we can try that a bit later. Then obviously, I'm first going to generate a classification for my LandSat 9 image. Okay, so I'm going to create a classification for my LandSat 9 image, and then I'm going to deactivate the LandSat 9 and I'm going to change it to Sentinel, and then create a classification for Sentinel. Now the features should be exactly the same irrespective of the LandSat, because it's for the same time period. So using my satellite here, I can actually identify features, and that should be prevalent for both those two images. So I don't have the issue of LandSat 5 that I can't use a satellite, etc. Then obviously I'm creating my training variable using the merge function for my classes or my categories, and then I'm creating my training for that. I'm going to train it, and then I'm obviously going to generate accuracy sample and a prediction sample or classification sample, which is 80 and 20. So the less than 80, that's my training sample for prediction, for accuracy, and this is my 80% of the X amount of ROIs that will be used for my classification. So there I'm splitting it between the ROIs for classification and the ROIs for accuracy. Now again, these are numbers, you can use it, and as I said, it's a random selection of those ones. Then I actually classify. Okay, remember, in my classification, I'm going to use the LandSat 9, which have LandSat bands as its, remember, LandSat bands as the bands that we're going to use for the classification, meaning the spectral signatures of these bands will be used for the classification. And so therefore, remember to make this an important point. So if we have Sentinel, then we have to change this to the Sentinel bands. Now what I can do is, you can't harmonize these bands because they are not equal in numbers. So you can't, like in some of the previous videos where we harmonize them so we don't have to jump between the two. Unfortunately, I can't do this in this case, except if we leave certain bands out. But then I think you'll miss important classification in the Sentinel. Anyway, so this is important to remember. Then we do the classifier, and then we create a visualization, and we classify, and then we create our accuracy assessment. Okay, so exactly the same as we did in the previous one. So let me do that, make it a bit smaller. Okay, so all I'm going to display is the LandSat 9 image, the Sentinel image. Okay, remember, I'm going to compare the classification using either LandSat or Sentinel to see which one is more accurate given my classes and my ROIs. Okay, remember the accuracy or the conclusion between these two will be only relevant for my specific class of identification and my ROIs. If I change the ROIs or the classes, I may get a different conclusion. But nonetheless, okay. So that's for that. And then I've got I run it, okay, and I've got my classification. Remember, in my classification, water is blue, vegetation is green, agriculture is this yellowish color, dark yellowish or gray yellowish, soil is purple or pink, mountain is this blackish color, and urban is red. Okay, so remember that. So that's my classification for this region based on LandSat 9 image for median image for 2023, and obviously my classes and their ROIs or training samples. Let me see, I get an overall accuracy of 73, let's call it 74%. Okay, so remember 74%. That is my accuracy. Okay, so let's have a look at LandSat Sentinel. Okay, so remember I need to now deselect LandSat and select Sentinel. Okay, so I'm going to go to my code. I'm going to find the location. So I'm in here. I'm going to deselect LandSat 8. Okay. Deselect LandSat 9. This is the one that we've worked. And I'm going to activate the Sentinel image. Now remember, I also need to change the bands in my code because I'm using LandSat of Sentinel now. So, okay, so I replace that with Sentinel. So that's the only two changes that you have to make. And you press run, and we should get the outcome in terms of the accuracy soon. It should come. Okay, so 89%. So that's quite a good level of accuracy. Remember, with this classes and this training samples or ROIs for using LandSat 9, we get a 74% accuracy, and then using Sentinel with the same classes and the same ROIs or training samples, we get an accuracy number of 89%. That's quite significant. Okay, but just on this point, let me quickly point out that we're using the normal classification method. Okay, remember I've also built in a classification using random forest. So we're also going to compare the normal classification with the random forest classification. Okay, but for now we're only comparing the LandSat 9 and the Sentinel images for 2023, and you can see there's now it's going to be very difficult to visually determine the difference between 74% and 89% at this level. So you actually have to side by side, and this is what we're going to do in the next video. We can create a side by side or a split image or split map, whereby we can then visually determine the difference between the 74% and the 89%, because statistically it seems like it's quite a big difference. Visually at this moment we can't really say too much, but anyway, so let's then, okay, so that is quite a big difference from 74 to 89 using the standard classification method. Okay, so that's quite a big difference. So let's quickly then as I said, we've built in two classification methods. We've built in the normal or the standard classification method, and we also built in the random forest method. Okay, so let's repeat this exercise using the random forest method, and I've went for 100 trees in my random forest. Now you can play around with that number, that's up to your discretion. Okay, I've arbitrarily just used 100 trees in my classification. Okay, so let's start again from LandSat. So I'm going to deactivate the Sentinel, and I'm going to activate my LandSat. Just make sure that it's also relevant in our classifier script. There it says, so it's LandSat. Okay, so let's run it and see what remember, for the standard LandSat classification, it was 74% accuracy. Okay, here we go, 80%. So that's the random forest, gives us 80% accuracy. So using the random forest gives us a better land classification prediction than using the standard method for our LandSat image. Okay, so that's quite an interesting increase, quite a significant increase again. And the classification will be loaded, but again, from this distance, it's going to be very difficult to see on the granular scale the difference. Okay, from here, and it's not side by side, it's difficult to visually see the difference. We know that statistically there's an improvement, but we can't visually from this distance actually see it. So again, as I said, what we have to do is to zoom in and create a split map to compare, and that's what we're going to do in our next video tutorial. Okay, anyway, so let's quickly go and deselect the LandSat image and go and perform it for my Sentinel. Now remember again, I now need to change the bands within the classifier from LandSat to Sentinel. Okay, so now it's Sentinel and I run my script again. So let's see what the accuracy number comes out. Remember, oh, in fact, it actually decreases. It actually decreases. It's still better. Okay, let's start from the beginning. We have a decrease in our overall accuracy using the Sentinel median image for 2023 from using the standard method to the random forest method with 100 trees, from 89% to 85%. Yeah, not a significant difference, a decrease, but still a decrease. Okay, so from the Sentinel point of view, in our case, it's better to use the standard classification method than the random forest method. However, we see exactly the opposite occurred with our LandSat image. In LandSat image, it's better to perform the classification using the random forest, 100 trees, than the standard method. However, in both cases, okay, in both cases, using the Sentinel is giving us a better classification than using the LandSat, whether it is the standard or whether it is the random forest method. So if this was our only classification or only classes that we're going to work with and the only regions of interest of training samples, then the conclusion would be to work with or to classify the ROI or the whole area using the Sentinel image and applying the standard classification method. If we were only working with LandSat, then our conclusion would be to work with the random forest method. Now, just interesting, let's quickly see if I decrease this forest, the number of trees to 10. Remember, it's 85. Let's call it 86%. For 100 trees, if I make that 10 trees, okay, I change the random forest number of trees from 100 to 10. Let's have a look and see what the overall accuracy now becomes. Whether it is better to go with, well, you see there is a better accuracy, well, by, yeah, almost 2%. Almost 2%. Goes to 87. So, the fewer trees that we have in our classification, the better for this particular exercise, for LandSat. It may not be the same for Sentinel. This may not be the same for Sentinel. So we have to be careful to make blanket conclusions and stuff. But it does seem like the standard method is the preferred option when we work with Sentinel, whereas the preferred option when we work with LandSat is the random forest. But in both cases, working with Sentinel is preferred working with LandSat because of it gives better classification. But as I said, we can see that via the statistics, but what we now need to do is to go and visually identify the differences. What is also important now is how can we improve it, okay, because there is some glaring changes. So what we can now do is to use a simple image and its classification, and then adjust our training samples, our ROIs. So where we see a specific training sample or ROI, let's say it's supposed to be urban, but the classification is bare soil, then we can move that ROI to away from the bare soil classification. So we can play around with the adjustment of these classes, or the ROIs in each class, and then rerun it to see whether our accuracy improves or not. And that will be also for a specific video. Okay, so this is just a quick video on classification, but more to do with the accuracy or the reliability of the classification. Because performing the classification is one thing, that's not too difficult, but to get the classification as accurate as possible or reliable as possible is quite another thing. And there we need some patience, and you need some comparisons, and you need some effort to specifically with your, because remember the classification is as good as your regions of interest. Those 50s or 100s or 200 regions of interest, that's where you classify, because you need to make sure that those regions of interest have a spectral signature that matches the feature. And that's going to be important. Anyway, that's going to be also a video tutorial for next time. Okay, so in our next video tutorial, we're going to create screenshots of the two, and we can split the screen, not just to see the difference in the statistics of overall accuracy, but also to visually see where the differences lies. Okay, well, thank you for staying or for watching this particular video. Remember to like and subscribe it. I really appreciate your support. I hope you will continue staying with me on this fabulous journey of remote sensing, and I'll see you on the other side.